Hello dear students, welcome back to the CS department. As we were seeing the first chapter highlights, there we have already seen the components of the motherboard in the last part of the video. In the components of the motherboard, we have seen different electronic components like BIOS, CMOS and the slots, ports, etc. Now we are left with the last component. And that component is such a component that will connect all the other components in the motherboard. Okay, means the processor has to be connected to the slots or to the ports, right? And there should be a medium how the data should travel from the processor to the other devices, correct? Means in the wire or the cable has to exist in between the components such that the data or the control signals travel in the motherboard. Am I right? So that component that connects the all other components is called as bus. Okay, bus is nothing but the collection of wires, correct? Collection of wires or cables that connects all the other components on the motherboard and that facilitates the ease going of the signals, control signals or data signals or address signals. Okay, so that is the main thing we have to discuss today. So the topics that we are covering today is the bus, memory, SMPS and UPS. Okay, so let us start with the bus one. You already know the definition of the bus. Okay, then there are two types of bus, internal bus and external bus. Now what is internal bus? On the motherboard, what all components are there? Okay, the bus that connects the components on the motherboard internally is the internal bus. Okay, but some peripheral devices are there, like mouse is there. It is not connected internally. A wire comes out of the processor or out of the motherboard and that is connected to mouse or keyboard, correct? So the external bus is the bus that connects the peripheral or the external devices to the motherboard. Internal bus is the cable or wire that connects the components inside the motherboard. Okay, now this internal bus is also known as system bus. Please remember, internal bus is also known as system bus. Okay, so now for say 3-mark question, we have a detailed system bus architecture. Now you can understand what is the system bus. It is the internal bus. Inside the motherboard, what all set of cables are there that constitute the system bus. Am I right? So here we are seeing 3 types of system bus. One is control bus, address bus and data bus. Okay, so 3 types of buses are there inside the motherboard or internally in the motherboard. Okay, now we need to draw this architecture correctly, okay, and explain it in few lines. So, coming to the control bus first. Control bus, as you know, is giving the control signals, correct? To switch on or switch off, to flow of the control has to be controlled, correct? It has to be transferred from the memory to the input-output devices, correct? So all these control signals are given by the control bus. That is the first one. As you can see, control bus is connected to CPU also, the memory also, and the input-output devices also. Okay, it is exchanging the signal, interchanging the signal, you can say. Means the signal can come from CPU and go to memory. Okay, or can come from memory and go to CPU. It is bidirectional bus. Please remember, control bus is bidirectional bus, correct? Because this control signal can come from any device and reach any device. This is the control bus. But secondly, when you come to the address bus, as you can see, from CPU, the address bus is originating and it is ending to the memory. This is very important. Okay, means what? CPU does not have any matter here. The memory has stored the data, correct? The memory has got the address locations. Am I right? See, you have 12 GB memory or 16 GB memory, 64 GB memory. When you say that, okay, the memory is the storage device, correct? CPU has to go to that place or that memory location and get the required data and come back. Am I right? So CPU goes and addresses the memory. That is the meaning. Okay, memory has got all the data in it, correct? And CPU just sends the address. It just sends the address. At this specific memory location, this file is stored. Please give me. When I say, so the CPU has to send the address through the address bus and it has to reach the memory. Okay, and it has to reach the memory. Whereas input output devices can give the memory location and can take the memory location. Here it can be the bidirectional, but CPU does not hold any addresses. The addresses are stored in memory, correct? So here it becomes unidirectional. This is the main thing you have to explain. And it actually specifies the maximum number of memory locations that a CPU can address. What is the meaning of this? When I say my laptop is a 32-bit machine or 64-bit machine, what do you mean by 32-bit or 64-bit? What is the meaning of that? One wire at a time can carry 1 bit. Okay, means 32-bit address can be found in the memory or 64-bit address can be found in the memory. That is the meaning of when I say 32-bit machine or 64-bit machine. It is actually specifying the length or the width of address bus. Okay, remember this. It is the maximum number of memory locations that a CPU can address. Okay, so that is all about address bus. And the data bus that carries the data, it is simple. Okay, from CPU the data can be sent and stored in the memory, or from memory the data can be fetched by the CPU, or sometimes input output devices need the data to be displayed or the data to be inserted. So the data bus is always a bidirectional bus. Okay, there can be 32 or 64 or 128 lines. Means 128 lines of wire can be there in the data bus. Okay, so this is all about the system bus architecture. I hope this is clear. Please take down the diagram and make a few points about each bus in this. Now, coming to the next part, and that is memory devices. So, in the configuration of the computer system, there are two types of memory devices, as you have already learned this in first year, the primary memory and the secondary memory. Am I right? The primary memory is the, you can say, the inbuilt memory, correct? It is already there inside your computer system. Okay, your primary memory mainly includes two types, that is RAM and ROM. RAM is the random access memory, correct? Random access memory is the faster memory, and you say it as volatile memory. What do you mean by volatile memory? Means whenever you turn off your computer, you shut it down, the memory is erased, correct? You cannot, without saving it, you cannot have that data stored. Okay, so RAM is the faster memory but the volatile memory. Okay, and in RAM you have two types, the static RAM and the dynamic. Okay, static RAM and the dynamic. Okay, the static RAM usually is used in cache. Okay, not the cash, not your money. Okay, C-A-C-H-E. This is sometimes pronounced as cache or cache. It is actually pronounced as cache. Okay, so in the cache, in your mobiles you might have seen this word. Okay, cache memory. So SRAM, that is static RAM, is a very high speed memory. So it is used in cache. Okay, it is but expensive. Okay, it takes more space. Okay, and its storage power is also less, but it is used for the high speed applications, that is static RAM. Now coming to the dynamic RAM, this is commonly used. Okay, what we have in our laptops is dynamic RAM, or in our mobiles everywhere. This is commonly used. Dynamic RAM is cheaper. Okay, consumes less power, not though expensive also, but slower than static RAM. That you need to understand. It is slower than the static RAM. Your dynamic RAM again is divided into two types: SD RAM and DDR RAM. Okay. Here, as I have said, the full forms are very important. Okay, please take it down. SD RAM stands for synchronous dynamic RAM. Okay, synchronous dynamic random access memory. Fine. And DDR RAM stands for double data rate random access memory. Double data rate. Okay. Why do you say this as synchronous dynamic RAM? It is always synchronized with the system clock. Okay. It is always synchronized with the system clock. Means it is understanding when the next signal is going to come and what data has to be sent. So before the next signal comes, it keeps the data ready. That is the smartness of this synchronous dynamic RAM. Okay, it is always synchronized with the system clock. So it knows when the next pulse is going to come, and hence it keeps the data ready by that time, and hence it becomes faster memory device. Okay. Similarly, the DDR RAM, it also works as SD RAM itself, but here it is called as double data rate RAM because the data transfer is going to take at the double rate. Okay, means double faster it is going to send the data. So it is named as double data rate RAM. Now these are the types of RAM devices. Static RAM of high speed, normally used in cache memory. Dynamic RAM, slower than static RAM, but cheaper and less power consuming. It is further divided into synchronous dynamic RAM, which is synchronized with the system clock, and double data rate RAM, which transfers the data at the faster rate or double faster rate. Okay. And the next one is ROM, read-only memory. As you all know, this is the permanent memory. Your OS, your backup utilities, your antivirus software, etc. can be stored in the read-only memory. Even when you turn off your computer, your OS will not be erased. Correct? Once the OS is loaded to the computer, it will be there itself because it is stored in the permanent memory, and that is ROM. Okay, why is it known as a read-only memory? Because you cannot edit what is written in this ROM. The OS, when it is loaded once, you cannot edit it. Okay, but further advancements have come in ROM. Okay, you already have studied this in first year. The programmable ROM has come, erasable programmable ROM has come, electrically erasable programmable ROM, PROM, EPROM, EEPROM. These are all the types of ROM you need to remember. Okay. And coming to so this is all about RAM and ROM constitute the primary memory, the inbuilt memory of the computer system. But there are many secondary memory devices, you all know, that can be connected externally to the CPU, and your secondary memory devices can be what? CD, DVD, or your SD card, your pen drive, okay, Blu-ray disc. So these all constitute the secondary memory devices. Why the secondary memory devices are needed? Because your inbuilt memory is of a small size. You cannot hold a huge amount of storage in your primary memory. Okay, and hence we always go for the secondary memory, where we can have the backup, where we can store a huge amount of data, mainly your HD, hard disk drives. Okay, your hard disk drives, your floppy disk drives, your SD cards, USBs, etc. are used in the secondary memory. Okay, so this forms the part of the primary memory and the secondary memory. Now coming to the next specific part of memory called as cache memory. As I said earlier, the cache memory. Okay, what is the use of this cache memory? Why is it used? It is normally used to increase the rate of processing. Okay, how does it increase the rate of processing? It is normally situated between the CPU and the main memory. Okay, the cache memory is always situated in between the CPU and the main memory, or you can say RAM or ROM. Means when the CPU needs some data, okay, it has to fetch from RAM or fetch from the primary memory, isn't it? But if some data is used more often, if you repeatedly use some data, such data will be stored in the cache memory. Okay, means what? You need not go to the primary memory and fetch the data. It already gives the data before it. Means it is increasing the rate of processing. Okay, so it is very expensive memory. Okay, it can be of a small size because it holds only the data that is used more often, or the recent data is there, no, that is held by the cache memory. Okay, now that cache memory also is of divided into some levels like L1 cache, L2 cache. Even some laptops have L3 cache also, level 1, level 2, level 3, like that. Okay, L1 cache is situated inside the CPU itself. Means with the registers, it is situated inside the CPU. Okay, means the processor has a small amount of memory. That is level 1 cache. Means it is so near to the CPU that whenever for processing some data is needed, it gives it immediately. Not even the nanoseconds of time is taken. Okay, that is level 1 cache. But it is only of 32 to 512 kilobytes. So small memory it is. Okay. Coming to the L2 cache, it is situated in between the CPU and the main memory, the level 2 cache. Okay, it is normally having 1 to 2 MB of size. Okay, so the recently closed tabs or the oftenly used data is always stored in this level 2 cache. Okay, so this is about the cache memory. Level 3 is there, which is bit slower compared to level 1 and level 2. Okay, so between the primary memory and CPU, this cache is situated, which is very expensive but gives the data at a high speed for the processing. Okay, this is about the cache memory. I hope this is clear. This diagram you have to draw and you have to explain about level 1 and level 2 cache, and do not forget to mention the sizes of them. Okay. Coming to the last part of this chapter, we are studying the SMPS and UPS. Now what do you mean by SMPS? Switch Mode Power Supply. Please write it down, the full form. Switch Mode Power Supply. Okay. See here, your laptop or your computer, your CPU is normally connected to the electrical outlet in your home. Okay, the electrical outlet is giving you 230 volts of high power, but your computer or your CPU needs somewhere around 12 volts or 5 volts of power, not more than that. Okay, means your huge AC power has to be converted to DC, correct? It has to be rectified, you say, isn't it? That is called as rectification in physics. So your AC has to be converted to DC and then given to the motherboard. Okay, means you cannot connect the motherboard directly to the electrical power outlet because your motherboard cannot hold that much amount of power. It gets heated up and destroyed. For that, you need a device in between, and that is called as switch mode power supply or SMPS. What does it do? It converts the AC power which is coming from the electrical outlet to the DC that can be held from the motherboard. Okay, a 12 volt DC you can say. So it is mainly converting AC to DC. It has two components. A power card plug is there. I hope you all have seen that 3-pin plug that you connect to the CPU. Okay, a power card plug and a fan. Why the fan is needed? When the motherboard components are getting heated up, to cool them down, a fan is situated at the back end of the CPU, even in the laptops. Okay, so that actually is the component of this SMPS, switch mode power supply. Okay, now this is one thing. And the last concept is UPS, uninterrupted power supply. You already know this. What is UPS? whenever there is a power cut, okay, you are working on the computer, the power if it fails, then the data that you have already typed gets erased, okay, means once the data is lost, RAM cannot retrieve it back. So what do? We use UPS, a standby UPS we use, okay, means for 10 minutes or 15 minutes it holds the power, it's nothing but the battery, isn't it? So until we save the data, the power is given by the UPS and you can store it and then turn the computer off. So this is uninterrupted power supply. Now this is also divided into two types, offline UPS and online UPS. First, see, this UPS can be asked for 3 marks, okay. You first need to write the functions of UPS, what does it do, and then write the types, offline UPS and online UPS. What is offline UPS? As I said just now, the standby UPS that can give the power of 10 minutes or 12 minutes or 15 minutes based on the battery, okay, that is offline UPS. Means for few minutes you can get the power from that, just to save the files and turn it off. But what is online UPS? Online UPS you use it at home and you call it as inverters, okay, means continuously the current is provided by the online UPS itself. The electrical current, whatever comes, has to go to the online UPS first and then it comes to your fan, your light, your computer and your everything. So this is normally known as inverter, okay, means continuous power supply is done using online UPS. Offline UPS just gives for 15 to 20 minutes, okay. This is the inverter, online UPS. So this is all about the UPS, offline and online. These are the types, okay. So here we have covered the bus topic, then the memory, in that we studied cache memory also, then the SMPS and UPS. Now this completes the first chapter highlights, okay. There are in detailed explanation given to each and every concept in the textbook. You can refer that and please make down the specific notes, draw the neat diagrams and get ready for the exam. All the best everyone. Thank you one and all.